going live. How about that one? There we go. We're live. Hello, everyone. Caradog is indeed at a wedding today. Hello, how are we all doing? Right, you've caught me you've caught me on unawares. I wasn't expecting you all. No, what actually happened was I was just sitting down to get started, and then I was like, oh, I need to adjust the camera the scenes for a solo stream, and then I got distracted setting them all up, and then looked at the time again and was like, whoops. So yes, hello everyone. How are we all doing? Fashionably late, as always. Yes, Facecam indeed. Right, I'm going to carry on just setting stuff up. This is Facecam with capture, so that needs to go there. And then this needs to be small, like that. I don't know how big to make it. Okay, it's going to be that big now. I've spoken, I've decided. Right, then I need bench cam with face. That's fine. Let's turn that one off, turn that one on. There we go. Ooh, that one's actually got good cropping on it as well. That'll do. Anyway, yes, how is everyone? Welcome on in. I was going to think about things to say. I'm just going to quickly scan through the chat. And yes, it is indeed another wedding. Caradog just knows a lot of people who are getting married at the moment. So yeah. Great something to calm me down. Yeah, great something to calm me down after you've just put in an order for parts for your new build. Ah, I see. It's always a bit nerve-wracking when you pull the trigger on something like that. I hope it all goes well. Floor cam. There is no floor cam at the moment. Soldering time. There will be some soldering today. Soldering is going to occur. Right. And yeah, it is pretty busy at the moment. Right, so I'll just quickly summarize what's going on. So I was going to tidy my bench this stream, basically, just have a big old sort out while we chatted and stuff. However, then something more interesting showed up, and I was like, oh, okay, now I want to fiddle with this. And this is actually quite a good venue for me to be fiddling with it on. This is going to be a bit of a test, some testing, so to speak. So, Kofifi. Hello, Pianov. How you doing? It's the worst kind of coffee. It's microwaved coffee. I went out to make a coffee about 10 minutes ago and had that horrible moment where you're like, man, I really need a coffee. So you go out to the coffee machine and you see the last coffee that you set on to brew that you forgot about and has just gone cold. And you're like, so I microwaved it. And it's fine. I'm probably going to have more than one during this stream anyway, so just whatever. Anyway, unsub for the dodgy kofifi. Right, anyway, as I was saying, so what am I doing today? So, today I've got bits. So anyone, for the 10 people out there who watched my Slime VR full body tracking video, I made a set of full body tracking widgets for use in VR chat and other VR stuff. And the way those things work is they use what's called an IMU, an inertial measurement unit. In this case, this is an IMU. This is a BMI 160, and this is basically an angle sensor. It senses angle and acceleration. So it's got an accelerometer and it has a gyroscope in it. And by combining the data from an accelerometer and a gyroscope, it knows how far it's moving and in what direction. So it can sense motion, basically. And so it then this guy here, this is a Wemos D1 Mini. So this is just a small dev board. So this guy monitors the data and it sends it back to the Slime VR app via Wi-Fi. So you put a battery on this, strap it to your body, and you have a motion and you have a body tracker, basically. Now these guys are BNO 085 IMUs. Now the BNO 085 is one of the best commodity IMUs on the market. These guys are the holy grail for IMUs. However, they're very expensive, which is why I didn't use them on my first set of trackers. BMI 160s are pretty decent and they're really cheap. So BMI 160s, these cost like £3 each, something like that. You could get them cheaper if you ordered them in bulk. So yeah. However, B&O 085s, these guys can be ludicrous money. During the silicon shortage, these guys could be like $20 a pop kind of thing. And if you want to build a set of like 5 to 10 body trackers, suddenly your cheap DIY full body tracking setup starts getting real expensive real fast. But the prices on them have come down. The going rate for B&O 085s like this is now about £9, which is far more agreeable, but they're still expensive. This is a panel of 28 of them. So obviously, like at £9 a pop, that's someone do the maths on that. It's quite a lot of money. But these ones are faulty, and these are actually the official Slime VR designs, and they had a design defect in them which they had to fix. They then got new ones that didn't have a design defect, which went into the production slimes, and they're selling all their defect ones. So I got these at £6 each, which is still quite a lot for a defect module, but it's still really, really cheap for a B&O 085. So yeah, £9 is still quite pricey. For a full module that's ready to go like this, it's not bad. So yeah. Anyway, so the fault that these ones have is they have a grounding issue. A couple of the ground pins are connected up that should not be ground. So what as a result, these particular BNOs draw double the amount of power that they're supposed to. They pull about 80 milliamps, where ideally they should be running at like 40 milliamps. So as a result, they'll drain their battery very quick. So what I want to do is, or the repair procedure for these modules is to remove the chip, cut the trace around the pins that shouldn't be connected, and put the chip back on again. And I want to see if I can do it. Because if I can consistently do that on all of these, I will have managed to buy myself a bunch of cheap BNOs, and at the same time I got myself a fun project and a fun little challenge to see if I could fix them, and an interesting story behind them. So I've got a breadboard, a test tracker, and a bunch of other wires, and I want to build up a test jig so I can test these, try and fix them, and then test them again. That's the game plan. And then sell them back. Well, I want to make a new set of trackers, because I currently have a set of 8 trackers that are with BMI 160s, and they're fine. They're okay. They work as well as you'd expect BMI 160s to work, which is fine. They're pretty decent, but they still have drift. When I'm in VR chat, I usually have to do a T-pose reset every 20 minutes, half an hour or so, because one or more of the trackers will have drifted out of position. And whereas if I want to build a new set with 10 of these, and for these I should be able to go for hours or more with no resets theoretically. That's the goal. And the remaining ones, all going to plan, I want to build another 2 sets which I can then sell to then get my money back. So that's the goal. That's the plan. Yeah, very labor-intensive repair, which is why Slime VR are just selling these guys instead of trying to fix them themselves. It doesn't, when I was doing the research, I was talking to one of the Slime VR staff people about these, because I basically said to them, I said, I see you guys are selling these. What's actually wrong with them? What does it actually take to fix these? I'm guessing it's not easy if you guys haven't just bodge fixed them all yourself. And yeah, when they said, yeah, you've got to take the chip off and cut the trace, I was like, oh boy, okay, it's doable. But when you're trying to do medium scale production of a product, taking off the chip, cutting traces, and no, they had to respin the board. So yeah. But for me, I have time on my hands, so I'm willing to try a labor-intensive repair. So the stream is going to be so much fun. Well, if I win, I've got a couple of methods for this. I've got So the two methods that I want to go into, the recommended method for fixing these is to use a hot plate. So I've got an MHP30 here. This is the Miniware mini hot plate. So it's a 30mm square hot plate, which is perfect for small widget boards like these. So I should be able to bring the board up to reflow, lift the chip off, and it should be very drama-free. And so I want to do that. I also want to try just hot airing one, just be a hot air station hero, which theoretically should be faster, and see how that works out. I want to test both methods and see how they work out. It's also an excuse for me to get practice using this, because I've only practiced with this once. I've never used it in anger, and just generally speaking, I have very little experience with hot plates, so I want to practice with this. So yeah, should be drama-free, buckle up, yeah. What's the tech difference between the BMI 160 and the BNO? So I don't know the intricate details, but the big reason why the BNO 085 is better is this guy is 9 degrees of freedom. That's the term. It's 9 degrees of freedom instead of 6. The BMI is a gyro and an accelerometer. The BNO has the gyro, accelerometer, and magnetometer. It's got a compass in it. It senses magnetic fields. And so that means it has just another, because it has the, someone tell me the word, I'm dying here. Because it has the compass in it, that gives it another reference point. Magnetometer. 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 Magnetometer? I don't know. A magnet thing. How do magnets, how they work? So yeah, because the reason why BMIs drift, and well, the reason why other IMUs drift is that if you have very gentle movement, like what I'm doing with my hands right now, that's slow enough for it not, it can detect slow movement, but it's going to ignore small movements to avoid jittering. You know, like for example, if I just flick the wires here, you see that bounce? It, you know, your software wants to ignore, it wants to smooth out the input. So if it's very slowly drifting like that, it's going to ignore that slow movement because it's going to think that's false input. And that's what drift is, basically. But if the IMU has a compass so it knows where true north is, it knows when it's slowly drifting and can ignore that movement and it can correct it. So that's why the BNO is more accurate. This is not without caveats. If you're in a room with a bad magnetic environment, like there's lots of metal shelving or something like that, that's going to screw up the local magnetic fields and it's not going to work very well. But then also these guys just have really good gyros and accelerometers in them as well. So the 9 degrees of freedom combined with the quality of them is what makes them a lot better than the BMIs. No, I'm done. I'm not going to say it. So they'd be willing for $1. Yeah, theoretically, yes. Now, again, you know, it would be significantly easier just to buy BNOs that aren't broken, but I fancied a challenge, basically. And yeah, I fancied a challenge, so I thought, whatever, let's go for it. Let's see what we can do. Anyway, so shelves are a VR safety hazard. They sure are. Graham must be fun. I'm bad at tongue twisters. I am bad at them. Okay, right. So let me show you first. Firstly, I want to set up the test jig. So what I'm going to do is I'm going to disassemble. This is basically a tracker just without the power setup, because all you need is the microcontroller and the IMU. Everything else is just the power input to it, the battery and battery management. So I'm going to desolder this guy and stick it on the breadboard. So then theoretically, I can then just start swapping out IMUs to test the whole thing. So firstly, I'll show you what this guy looks like in the software. So I'm going to power this guy up. It doesn't do anything particularly entertaining other than just blink a light. And what I'll do, if I go to, let me get my quad view working. Okay, that looks pretty good. And just wake this guy up. And, right, I'm going to, remind me later, I'm going to zoom in. Oh my God, please, there we go. I'm going to zoom this guy in. There we go. So there's our power consumption. So my BMI test module pulls 80 milliamps total. So that's the micro and the IMU. The entire thing runs on just shy of 80 milliamps. My God, there he is. Hello, Paige. How's it going? Don't confuse drift with variation. Yeah, my terminology might be a little bit loose here. So by all means, feel free to correct me on stuff. So, right. And if I switch over to, let's see, I'm going to put that up there. I'm just sorting out my windows at the moment. Right. Am I good for desktop show? Yes, I am. Right. So desktop, and let me just sort this out. Instaface. Put myself in the corner. I was trying to sort this out before we went live, and then I spotted the time. And display capture. Primary monitor. There we go. What on earth is that in the top right? That is something visible that shouldn't be. That. There we go. Go away. Be gone. All right. Right, so here's the Slime VR server. Let me just orient this window. And let's just click on that and preview. There we go. Right, so from here, you can see I've got a box that's moving on screen. That is the preview of the IMU being turned. So you can see that the software is monitoring the orientation of the box. So that's how we know it's working, basically. It hasn't been calibrated, but that doesn't matter. We can see that the thing is working. It knows which way is up. That's the important thing. That could be powered by a solar and motion charge method. It could be, but also you can put on a 1 amp hour. You can put a 1 amp hour LiPo on it that will charge, that will run it for 12 hours without being recharged. So I think this came up last week, actually. This is one of those classic examples of it's low power enough that you could use some kind of energy harvesting method to power it, but also it's so low powered that even a small battery will give it such a long runtime that it really doesn't matter. But yeah, put it on your glasses, cheap VR. Well, yeah, maybe. You're tired. Well, hello, tired and stuff. How goes things here? They go all right. I've just I've immediately exhausted myself trying to explain what I'm going to be doing today. Bench cam with face. There we go. So yes, I'm fiddling with some Slime VR trackers. All right. So anyway, so here's our baseline tracker. So what I want to do now is I want to disassemble this and put it on the breadboard, and so we can get into a position where we can connect up a BNO to it. And then when we put the BNO on there, we'll need to flash the firmware on it with with firmware that is configured for the BNO. Then once we've done that, we can do the same thing. And due to the miracle of my USB power meter in the bottom right there, we should be able to observe that it is using drastically more power than it should do. So then we have our before test. Then we try and fix one, we put it on, we test it again, and we should see that the power consumption has dropped down to a sensible level. That's the plan. You got yours already? No, well, I have homemade trackers. I've got a set of homemade slime trackers. However, these are the sensors that the official ones use, and I want to make a new set with these sensors. So, quad screen hype. I know. Heckin' Paul Daniels is going to come after me. Right. Still need an MCU to read. That's what the D1 Mini is for. ESP32. You can use an ESP32. The reason why everyone in the Slime VR community they swear by the D1 Mini, because this guy is the smallest, lowest power one that has the grunt and utility to do this. The bigger MCUs are all perfectly adequate as well, but they use more power. This is the one that you actually want to use in your actual tracker just because it's small and low power. I think there are some newer MCUs out there that use even less power than the D1, but the D1 is cheap and it's everywhere and it's very well documented, so it's generally the weapon of choice. So yes. I know you said, but what brand microscope do I use? I use an Andon Star. And I currently use an Andon Star AD407. I've got a 409 on the bench behind me, but the HDMI output on it doesn't work at the same time as the screen. So it's not very good for streaming. So, okay, right, let's get to work. So what I'm going to do now, I'm going to warm up my soldering iron and I'm going to take this guy apart and put it all on the breadboard. So I'm going to get to work on that, and we can have a chat. We can maybe talk about tech. Let me just get my soldering iron because it's over here. Still over here from last week, actually. I've not used the soldering iron all week. Right, soldering iron. Yeah, that's it. That's the whole lot. Right. Off topic, but I'm in a quandary over which way to go with your gaming rig. I misread quandary as corduroy there, and I was like, why the hell are you in corduroy? Anyway, from a 3600 to a 5700X, or an RX 5600, 3600 to 5700X. Oh, I see. CPU or GPU, or 5600 XT to a 6650 or 7600. I would say GPU, because for gaming, GPU is the last word in games. Well, GPU makes up the vast majority of gaming performance, so that's what you're going to feel the most. And so GPU is actually going to get you a measurable difference, whereas CPU, you have to be really limited before that really matters. And at this point, I would be trying to eke out that 3600 just long enough to get you past this platform. So that way, when you actually upgrade your CPU, you're doing CPU, motherboard, and RAM. That's my opinion on that. Unless you come across a cheap 5700X. Like if you come across a cheap 5700X that you can just drop into your computer, then that will also work. What do you think of the new Be Quiet case? What model is it? I don't keep up with Be Quiet stuff that much. Let's see. Let's go to microscope while I desolder this. Actually, no, that's overkill. I don't need that right now. Let's just zoom in a bit. Let's see. Boop. Yeah, that'll do. Okay. I need some tweezers. Those will do. Right, so I'm just going to pull all of the wires off of this. That's all I've got to do right now. Take these out. It's a pretty simple design, these trackers. All you really have is you've got power into this board, and then you've got two I2C lines, so data and clock, going to the IMU, and two power lines going to the IMU. And then there's an extra wire running across the board here, which is a voltage sense wire, which allows it to check the battery voltage and thus how much battery is in there. Whoop. Incidentally, Paige, with your brother waiting on slimes, they are actually shipping now, so he's probably very close to getting his, I would imagine. Balls, I need a board holder. Doesn't matter. It's not going to take long just to pop these all out. There we go. Right. That's that guy. And I'll quickly clear these pins because I need to put some actual pins on it to put it into the breadboard. Where is my... I need my heckin' vise. I've got to clamp this guy up. Oh, there it is. not far away. Right, let's zoom out and put it in the vise. I need a small board holder for doing this. I don't do this kind of thing very often. However, I need a small board holder so I don't have this enormous chunk of metal when I am doing stuff. That. Whoop. There we go. And now I shall wick that clean. Where's my wick gone? There it is. Nothing is where it should be because all the soldering gear is on the other bench from last week. I need to make the chat slightly bigger as well so I can read it faster. There we go. He was talking about them earlier today. Complaining about them having to leave Europe to go to the US before being sent back. Oh, yeah. So the official Slime VR trackers, because they were sold by Crowd Supply, which is a US company, they had to be produced in Europe, shipped to the US to Crowd Supply, and then shipped back to Europe again for the people who are actually buying them. Really dumb situation, but it's just kind of the way it worked, really. Thankfully, it's not going to be like that forever with Slime VR because they're just going to be able to sell them directly now. But, wow, there's more solder in these. I need to open up this wick. I'm just going to splay out this wick a little bit just so it actually holds more solder because I'm being really wasteful with it at the moment. There we go, that's better. I say, now the wick stops working. There we go. Clear. There we go. Right, that's all clear. And I need a cotton bud and some alcohol just to clean up. 1 AM in the morning here. Chris, you're mad. What are you doing here? Go to bed. There we go. This start bit is going to be a little bit slow while I just get prepared. I was agonizing over how much prep work to do for this stream. I was like, should I do all of this bit before we start? And I was like, well, no, then I'm just taking away content for the actual stream. Especially because I can't guarantee that any of this is actually going to go to plan, and this might be a short-lived adventure. In which case, at least I did something interesting. Okay. Solder sucker go brr. It does. There we go. However, this is cheap wick, and it's, yeah, not super matter. Okay, right, that's fine. So I want to put this on here, and let's see. I'm going to put it. I'll put it over here, I think, so the USB port is accessible on it. Although, actually, if we power the whole thing over USB, which I'm probably going to do anyway, we don't actually need the power module for this breadboard. So I'm going to take that off. Right. Let's get some pin headers. Those are no good. These should do. I need, so for pin headers, I'm going to need split amounts. Okay. Might break, yeah, I'm going to break some of these up. I have got a whole bunch of pin headers, but I'm going to try and use them a bit efficiently because I'm not sure how many I've actually got or where they are. All right, so stick some pin headers on here. Solder sucker is 28 times 28 is less wasteful. Yeah, this is true. However, it's not like any of the stuff that we're wasting has a lot of value, so... Short adventures are still adventures. They sure are. They sure are. Prep work? I do prep work? Never. Does saying breadboard ever make you hungry? Not especially. I don't use breadboards that much. Ow. Breadboarding is, for project stuff, is something that I want to do a lot more often. I like making widgets like this. I just never have a reason to make them. I really want to get into just building small project stuff like this, but it's just finding stuff to do. Right. Ow. This is going terribly. There we go. Right, that is 5 volt and ground. Then I want the 3.3 volt pin over there in the top left. So I'll put another 2 pins up in that corner. I'm basically going to do all the corners on this. Yeah, let's break up these pins. I'm basically going to do the corners because that means that it will have stability in the breadboard. And I don't have to use a whole bunch of pins that I don't need. Right, let's try this slightly differently. I'm going to flood that hole and then feed the pin in there. Purge, no. Right, is that flat? There we go. I'm not particularly fast at doing this kind of thing. Okay, this is fine. Right, and since I've now decided I'm just doing the corners, I could just turn the board over and then I don't have to hold things up in... Oh no, I'm soldering... Idiot. I'm soldering the top side. For a moment, I thought I'd had an epiphany. An epiphany. When I had learned to speak properly. You always burn your fingers soldering? Yeah, that's part of it. The trick is never to burn yourself badly. And then it's always just a ow, ow, instead of a oof, I've actually injured myself. Like, I'm holding the bottom of these pins as I push them up through the board. And the bottom of the pin gets hot enough to burn my finger. So, you know, I've got to be quick, because if I take a second too long, I'll burn my finger. But like, I'm not going to singe off my fingerprints or anything. It'll just leave a mark. All right, one more. Whoop. Okay. I'm going to rearrange this over here so it's more accessible. Cool. So now we have our micro with legs on it, so I can put this into the breadboard. So that's now going to go in the middle somewhere. Oh, it doesn't straddle very well. I've got to bend these out slightly. Hang on a minute. That should do. Good. Cool. And we've got just enough pins exposed that we can actually hook that up. So now I'm going to do the same thing with this BMI 160, and then we can actually wire it all up again. Do the same thing, and we should find that we have a widget that does exactly the same as it did before, except now it's on a breadboard instead of wired. We're deconstructing this. You like ceramic tweezers? Yeah, I've got some ceramic tweezers that I use now and then. They're okay. The only problem, the ones that I have aren't very accurate. I've got some really sharp ones somewhere, but I've not been using them because I've been saving them for another project that I did spot earlier on today and was like, whoops, I should probably get on with that. Not super fussed if I damage this wire. Wire is cheap. There we go. Okay, and I'm going to just clear those holes just so I can put a pin header on this, and then we'll just use a long pin header. Come on. Let me be... Okay, that's good enough. I'll make it work. Right, pin header. Whatever you would call this. Oh, this is going to fight me because I haven't cleared enough of these. Might be able to walk it in. There we go. Oops, that's hot. Am I still on shot? Yeah, I am. Good. Cool. Zap these. Trying to be quick because I've got my soldering iron too hot for this actually. I'm just going to come down a bit. I'm sitting at 400 for boards, but and like this is through hole. You don't need that kind of temperature. That looks good. Right, I'll give that a quick clean up. Toothbrush. Toothbrush. Nope. Okay, no toothbrush. Just cotton bud. Oh, it's hideous. It's hideous. It doesn't even matter. We're going to stop using this as soon as we've confirmed that it works. This is just for the control test. All right. Okay, I'm going to catch up on chat. I thought chat would be easier today because I was soloing, which means I don't have to concentrate on Caradog as well. However, it's surprisingly difficult to do this. What wick do I use? This is just some cheap eBay stuff. It's Silverline brand. Like, this isn't good wick. Like, it isn't pre-fluxed or anything like that. So I have to add my own flux. So, not recommended, but cheap wick does work. It's just not very good. Oh. Okay. Right. Can recommend for soldering people to use a fume hood or do it outside? Yeah, it depends on how much you're doing it. Like, if you're doing a little bit of hobby soldering just then, you won't immediately perish. If you're soldering all day, every day, then yes, you should have something in place for it. But a common misconception that people often have is, you know, when I'm sitting here soldering and there's fumes coming off of the solder, I'm not sitting here huffing those fumes. You know, you don't just sit there and sniff it all up as it comes up into your face. You hold your breath, and then when it clears, you carry on breathing. Right. That goes on there. So, now I've got, I hope these are what I think they are. Yes, I have a load of jumper wires. So now I can jumper all of this up. So, now to make this guy work again, we need ground Actually, I'll put ground and power over to the actual bus bars. So ground, 5-volt power. Everyone can get really mad at me using the wrong coloured wire. This actually happens. People got, in this week's video where I was doing power injection, people got really mad that I was using red wire as for a ground wire. I was like, it's fine. I'm not an incompetent sometimes. Right, what's the pinning on this? Have I got another? No, I'm gonna have to pull this out so I can see which pins go where because I've forgotten. Come out. So that's going to be in the board like that. Right, SDA and SCL we need. So that is the 3rd and 4th pin. So it's data, clock, ground, power. Data, clock, ground, power. Don't let me forget that. Get back in there. There we go. Right. So, data, clock, ground, power. So the IMU runs on 3.3 volts. So we're going to take the 3.3 volt pin off of the MCU for this. The MCU has a built-in 3 volt regulator. So it takes 5 volt from USB, and then we have the main 5 volt, and then we have a 3 volt secondary rail that we use to power other things. Oh no, some of these wires are all different lengths. I hate it. That's probably what the colours indicate. It's fine. Right, power. Then it needs ground. Jump that over to the ground rail. Then we need data. Oh, I've not wired up D1 and D2. I used RX and TX, which we're not allowed to use. This is wrong. I need to fix this. That's fine. Let's just lift the MCU back out. I've got to move some of those pins. You can't use blue for ground. I will. I can and I will. Oh, my days. Okay, right. I hope this isn't making too much scraping noise into the mic when I open up this thing. It's very crusty. I'm going to grab some pliers. Be sensible about this. That'll do. Not perfectly flat, but it's good enough for breadboard. Is that a Pinesil 2? Yes. This was another thing that one of my backup plans today is that's my Pinesil 2, and I actually want to modify this because my Pinesil 1 has the sleep sensor in it. That flashing is because it's cooling, by the way. When it goes on to heat, it doesn't flash. But yeah. My Pinesil 1 has the magnet the Hall effect sensor in it, so when I put it in the stand, it automatically sleeps. And I actually want to take this apart, take that Hall effect sensor off, and put it in my Pinesil 2. So that's another thing that I will do if we run out of stuff to do today. Because the Pinesil 2 also has Bluetooth in it, and another idea that I kind of want to do is get the Bluetooth working, because it can give me temperature monitoring, which I could have on screen so people can see what temperature the soldering iron is at, which is kind of cool. Let's get this guy fitted back in. There we go. So now we've got D1 and D2. And I've completely forgotten which way round they need to go. However, I've got the reference in front of me if I go and grab it super quick. Let's see. So advanced. Right, data is D2. So we want D2. D2 goes to there. And then finally, there's another one. Finally, we need D1, which is clock, to go over to there. Anywhere will do. There we go. All right. So we've now wired this thing up on the breadboard how it was previously wired with physical wires. So now I should be able to plug it in and it should do exactly the same thing that it did before, only now we can hot swap modules out of it, which is the idea. So let's put those pins to one side. Keep the bench a little bit tidy. And plug in power. Which way up? That way up. It's alive! Okay, and one more time for posterity. As you can see from the USB power meter, it's using exactly the same amount of power that it previously did. High 70s, about 75 milliamps, looking for 80 milliamps. And if we go over to Slime VR, it is still working. So Slime VR is still detecting that as a, I'll hold it up there, you can see as I turn it around, it detects its orientation. So we have our test jig now. That's what we've achieved here. We've now built a test rig where I can now swap out the IMU for different IMUs to check that they work. That's what we're trying to achieve here. Firmware update first. No, I'm running old software and old firmware on all of this, but that doesn't matter because none of that will affect the power consumption in any meaningful way. So yeah, I meant to update to the latest version of Slime VR just because this is on 0.6 and they're on like 0.9. No, they're on version 1, I think. Yeah, this is an ancient version of Slime VR, but none of that matters for what we're doing today, so I'm not going to bother. Oh, wait, no, firmware. Yeah, for the different IMU, you're right. We do need to change that. So, yeah, what I'm going to do first, I'm going to snap out one of these BNOs and get a pin header on it so we can plug it in. So, and then we need to update the firmware so it actually is ready for the BNO. So now I've got to get one of these out without breaking everything. I've never done this before. I've never actually snapped off modules from a panel like this, and this is a really thin board as well. I'm just going to try and do it by hand. Here we go. Just try and get out one for now. There we go. Right. Let's unplug you. Okay. You would need pogo pin type connectors to do all these boards rather than soldering each pins. Yeah, agreed. Pogo pins would be good. Like if this was like a production test jig, you would do it with pogo pins. For me, I've only got to do a couple of these. Like doing this on a panel of 28 boards isn't a huge amount, and also I'm not time constrained either. So, right, let's retrieve this guy again. So firstly, just for posterity, I'll just quickly perch that on the end. We'll just do a quick comparison just in case people want to see what the visual differences between these are. There's not much to it, but... oh, this isn't going to work with the things. Hold on. I'm trying to figure out a way to get these two at the same height. There we go. Because when you look at stuff on a microscope, suddenly height matters. Right. Oh wow, the microscope is going in way too far. Capture. Turn that off. Why isn't that working? Oh, there it is. Oh my days. It's there. I was like, where's the capture? There's the capture. And let's just add my face in the corner. Instaface. Oh. There we go. Oh, this is as far as I can come out with the microscope. But yeah, okay, it's hard to see. At any rate, there's the BMI. This one's a bit mangled where it's been reflowed many times because it's one of my test boards. And there's the BNO. So the BNO is slightly bigger, but that's mainly just because it's got more pin outputs on it, I think. But yeah, there's a lot more going on with the BNO actually. It's got its own. It has its own oscillator and everything. I think that's a crystal oscillator, that T204 chip. But yeah, all right. You love the sound effects, yeah. Okay, right. So at any rate, that's that. Let's go back to Benchcam. And I'm going to grab another pin header. So I can do the flashing when I've already put the other IMU on. So we'll get that done first. Right, let me grab another pin header. So it's a pin header with a bent pin. There we go. So, oh good, it is labelled. It's just labelled in really small writing. So there's two ways of interfacing with this one. All the important pins have castellations there, so it can be integrated into another board very easily. You can just solder directly. However, we can also use these back ones here, which is probably what I'll do to keep those ones fresh. So I believe the main 4 pins are the only ones we need. So SDA, serial data, serial clock, ground, and 3v3 are the ones that we care about. The SDO pin, that one is for the address. If I was running a widget that had multiple sensors connected up to it, because you can have one board with multiple sensors, this address line would need to be terminated, so the microcontroller would know the numerical numbers. So it would know which one is sensor 0 and which one is sensor 1, for example. However, for this setup, I can actually just leave it floating and it should still work. So, can you not cut the traces without desoldering? Unfortunately not. We'll get to that. I know it's taking me ages to get to the exciting bit. However, I will show you why that won't work in a moment when we get there. Right, I'm going to do that 4 bit on the bottom there. So let's put pin headers on this guy. Scrape, 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 scrape. The soldering iron. Solder. All of this you've got to do 27 more times? Not quite. Once we've got the jig set up, it will be much faster to do this. And I'll be able to swap stuff in and out faster. Things are going slowly at the moment because I'm kind of just figuring out how it's all going to be. And like once I've got a method tracked down, I'm probably not going to be I'm not going to be doing before and after tests either. I only need to just do a quick solder, and then I could probably I could put on one, and that's probably good enough for a quick test, just a press test, and that kind of thing. Right, okay. I've just unscrewed that one. I didn't mean to. This will do. Oh. My God, Graham, just put it back in the vise. Why are you making your life harder? Right. There we go. Good. 3v3, ground, clock, data. Bang in. Okay, right. The breadboard. So, D2 is data. So we've got data, clock, ground, power. Data, clock, ground, power. Good. These pins are in the same orientation, so I don't need to move anything. I could probably swap all of these pins around so this guy hangs off the side of the board and is easier to get to. And that's what I'll probably do for longer term testing, but this will work for now. Right, so that goes on. So now I'm now going to plug in a different USB cable. And flash the firmware on this guy. So let's plug this guy back in. Right, so I've got a USB cable that's going back to the computer now, so I can actually serial link. Okay, firmware tracker. So let's get the desktop capture. So online firmware flasher. So we're running a D1 Mini, data 2, clock 1, enable LED, and then we're using a BNO 085. So on a real tracker, we'd want to set the rotation if appropriate, but we don't need any of this stuff at all. We just need it to know what a BNO is. And let me see, we're going to need Wi-Fi. I'm going to put in the Wi-Fi settings just so it works without the USB connection. So I'll just quickly switch back to another screen while I type in the Wi-Fi settings. This can be done after the fact, but it's easier to do it at this point. Right, continue. And desktop. All right. Connect to serial, COM6, connect. Okay, and we are flashing firmware, which is not terribly exciting to watch. It's just a progress bar. Also, not being on stream or recording would make it a lot faster as well. Yes, definitely. Yeah. Most of what this is more or less a practice run, because I will probably make another video about building Slime VR trackers at some point. It probably won't go on the main channel. It might do, because it probably won't, because the last one didn't go so well. But I want to do it for the sake of the Slime VR community, because they do care about this stuff. I think they will find it very interesting to watch someone fix these ones just for the sake of it. There's people in the Slime VR community who already know this stuff because they figured out what was wrong with these and stuff like that. And they did really clever stuff, which I'll talk about when we get to it. What I want to do here is figure it all out. So then when I make an actual video, I already know what I'm doing. So, did you know that AI can listen to keyboard strikes and predict with 95% accuracy? Cool. Someone's going to know my Wi-Fi password. It'll be devastating. It almost certainly needs to be trained. Okay, right. So, firmware uploaded. Your tracker is set up. Slime VR. So if we go over to home. Good. So our tracker is detected. Is it picking stuff up? Preview. Right. So no. It might need rebooting. I'm going to switch it over. I'm going to switch it over to the other USB cable, which is power only. And then we might need to calibrate it. Oh, look at that. Right, so there's our high power consumption. 185 milliamps. The previous one was 75. So this boy be thirsty, yo. God, that's burning up. That's a real hot boy. Okay. So, okay, so there's the high power consumption. So now I want to find out why it's not working. I haven't used a BNO before. I don't know if this needs calibration. So I'm actually going to go back over to the serial link, and I'm going to hope that the serial link will tell me what actually needs to be done with this. So check power. It should not get very hot. That's the problem. These guys are faulty, which is why it's getting hot. So yeah, it is getting hot because it has a fault. That's what we're here to fix. However, I need to get the test rig going first. So I'm going to go over to the serial console and see what that will tell me. Right, sensor 1 doesn't respond. Okay. Going to unplug that. I'm just going to look up what I actually need to do to set up the BNO. I don't know what the calibration. Sensor 1 doesn't respond. Okay, maybe it does need the other one hooked up. I'm going to check the actual reference diagram. One moment. Slime VR docs. I might have been wrong about the address line, so I'm going to check that I've got my address line set up correctly. Let's go back to that view. Actually, let's go back to desktop. So, BNO 085. Oh yeah, there's another line we need. We need the initialize pin, apparently. I don't know exactly what this pin does, but apparently we probably need it. Does the Adafruit version need it as well? Yeah, we're missing a pin. INT is probably initialize or something like that. It tells it to switch on and start running. So what pin do we need for that? All right, so there is an int pin on the castellations. I'm going to check if there's one on the other side. Roll for int, yeah, interrupt. Oh yeah, that makes sense. Yeah, there is an int pin on the other side. Okay. I need another pin on that. I'm just going to do a very quick and dirty solder for that extra pin that I've missed off. Bench cam, there we go. I'm going to steal a pin off the end of my BMI. Whoop. And solder it to the bottom of this guy. Alright. It's taken me a lot longer than I planned to get past this initial section. However, something, are you not entertained? Interrupt, yeah. Right. The dirtiest of soldering. Wow, that's not salt. That has not flowed at all. However, we're going to take these pins back off anyway, so I don't particularly care. All right, put that back on. So we need those guys. Let's just check my pinning again. 3v3 to 3v3. All right, I need an extra wire. Okay, so we want D5. Sure. Oh my heck, we've not got a pin. Can I be just really cheap and rude and just stick it in there? Oh my god. The temptation to just solder the jumper wires directly is overwhelming, and I must resist. I must not be that horrendous. This is why development takes ages. There's so many things where you're just like, oh, just do this. And it's like, there's always something that you forgot to do or didn't think of. Need pogo pins. Yeah. Pogo pins would be nice, but I don't have any. Like I said, once I've got this figured out, it will go faster. But this first stage is just figuring out the test rig. Alright, let's just get that vaguely straight. Ow. There we go. Back in it goes. This is why I use full-length pin headers as well. I cheaped out and wanted to use the existing ones I had kicking around. I've got long ones. They're just in another packet. Alright, that goes to int. We now have an interrupt pin. Alright, just put a full strip in. Yeah, it's what I should have done. It's what I should have done. However, this is where we live now. Okay, right. Let's see. What does this board do now? Ba, ba, ba. Right, is it connected? Ooh, it's reading. Desktop view. Preview. Haha! There we go. It works. So again, obviously, like, it probably needs calibration and stuff like that, but that's not what we care about right now. So what we care about is now we have B&O 085s. Oh, let's just plug it in using the power cable. B&O 085s that are using too much power. So start this guy back up. Wait for it to connect. Give that a reset. I think the Wi-Fi settings might not have taken on this one. Sometimes it takes 2 attempts. Oh, no, there it goes. Oh, that's interesting. It's connected, but it's not tracking now. Let me just try that again. Serial console. Oh, it's not connected to serial, yeah. Oh, it's not giving me a readout now. Okay, it doesn't matter. It worked once. That's what we care about. It worked once, and it's using too much power. We've proven what we need to know. So now I can try and fix this module. So you need one D1 for every sensor. It depends on what setup you're using. The way Slime VR works is typically you're going to use one D. You're going to do, let's say you're doing a typical setup, which would be 8 trackers. So that's feet, ankles, waist, and chest. Oh, thighs as well. There we go. There's your 8. So feet, ankles, thighs, chest, waist. That's the 8 setup. Now, typically, some of those you can put 2 sensors on. So, for example, the ankle sensors, you can have a D1 on your ankle that has a sensor for the ankle and another sensor for the foot because they're right next to each other. So at that point, you can have one MCU for 2 sensors. So you don't and that's known as like a 5+3 setup because you've got 3 of the sensors are just an extra sensor connected to another MCU. There is such a thing. There is another setup called an OctoSlime setup where you have one controller with sensors going out to all, and then you have like something you wear around your waist, and then you have a wire going down each limb. There are pros and cons to both setups, basically. So yeah. All right. Okay, so we have tested this, we have made it work once, and so now I'm going to try and fix it. So I'm going to remove these pins, and now we're actually going to take this chip off and try and repair it. We've seen it using too much power, and we've seen it track correctly. So now if we work on it, and it then starts using less power and still works, then we win. If it uses less power but no longer tracks, we know that I killed it. And if it stops working altogether, we also know I killed it because it was working beforehand. We are ready to actually try and fix something. So I'm now going to remove these pins so I can start doing stuff. Slow going, but we're getting there. Trying to be methodical. Right. No arms. You can have sensors for your arms as well, yeah. It depends on what you're doing as to what you might need. For most of the time, arm sensors aren't super necessary because most systems can figure out where your arms are pretty well from the angle that the controllers are at. Because when you think about it, you know, if you're holding a controller in your hand, if you're holding it straight out, in order to have your hand at that angle, your elbow has to be around here somewhere. You could do that, but that would be uncomfortable. So your elbow is probably going to be sticking out when your controller is at that angle. So a clever system already knows roughly where your arms are. However, if you're doing stuff that involves elaborate arm movements, dance or anything like that, having arm sensors is very beneficial. And my next set, I'm going to add arm sensors, but I'm doing that because I can, not because I need them. Right, I'm just going to clean this board up so it's nice and clean before I start doing anything with it. We are on shot. Yeah. Yeah, you generally don't need shoulders, just upper arms is all you need. Slime VR can track lots of other places as well. It has enough of a setup to be able to do full body motion capture, like so much so that you could use it as a stand-in for motion capture for animation rigs and stuff like that. But this is largely an experimental use of it. It's one of those, this isn't what it was made for, but it's also something that it can actually do. All right, I left one hole full there, but that doesn't matter. I do want to make sure it's flat on the bottom, though. Yeah, that's not flat on the bottom. So I want to make sure this guy's flat on the bottom because I'm going to use the hot plate. That's going to be my opening gambit. Yeah, the headset tracks. That's right, yeah. The headset is the authority. In a system, generally speaking, in a system where you're using Slime VR, the headset is the only quote-unquote true position you have, because your lighthouses or your headset, that knows absolutely where it is in the room, and all of the slime trackers are solved from the position of your head. So when you do a reset, if your head is here, your chest must be here. So when you do a reset, the tracker will default to being here, and it will calculate movement from that point. The head is the only thing where it actually knows where anything is. There are exceptions to that rule, but broadly speaking. So yeah. Does it have a housing it goes into? They can do, yes. Let me bring up a picture of the actual official slimes, because I've got it to hand here actually. Hold on. Introduction. Let me find... there we go. Desktop. These are the official slime trackers. So these are custom boards, and these basically strap onto your arms and legs. And you can see from the size of the USB-C port here how big they are. So they're about sort of yay big kind of thing. They're not very big. They're smaller than you think they are in real life. And yeah, you can do 3D printed housings for DIY ones. My current ones have no housing. I have ghetto slimes at the moment where they're just heat shrunk wrapped. But the new set that I'm going to make will have 3D printed cases because I have a 3D printer now. So yes. Right. Okay, so let's get to it. Right, now comes the exciting bit. So I'm going to quickly bring up... I'm just going to bring up Discord for a moment because I was talking to a chap who gave me advice on what reflow temperature to go for. Right. So my recommended reflow temperature is 235, which I thought sounded low, but I've gotten very little experience with hot plates, so that's where I'm going to start. So let's get this boy warming up because it's going to take a while to warm up. I'm going to plug that in there. This wasn't the exciting bit? Yeah, I know. Right, let's take that off. So, heating, temperature. This is the second time I've used this ever. I'm in settings at the moment. Right. M1 temp. Oh. Can I set that? Oh, setting. There we go. This thing beeps. It's very annoying. Right, let's just go to 235. 235C. Long press to get out. There we go. And heat. Low voltage. Are you sure? Oh. Let's try plugging it in again. Was I off shot for all of that? Low volts. Oh. I'm not sure why it's saying that because I'm plugged into a Type-C thing. Let me just try rebooting my Type-C adapter. Just in case it's not sensing properly. Otherwise, I'll get a different one. Try that again. There we go. Now it's doing the thing. Right, so this guy is now heating. Oh, that's the tilt sensor that time. Okay, that one was the tilt sensor. Unsurprisingly, the hot plate doesn't like to be pushed over while it's heating up. So, however, the problem is because we're on a top-down view, it's difficult to show you the screen. I'm going to see if I can position this in such a way that you guys can see what's going on. Ugh. Does that get you past there? Maybe. And then... Oh, so close. There we go. All right. Now you can see it warming up. Right. It is warming up. And I should probably put this guy on top now so it can actually do the thing. Right, so this is now warming up the board. So this is the first time I've done this with a tiny little board like this, so I don't know how well this is going to work, but, you know, here we go. Oh, we're just about on shot. Good. Right. So, oh, there was... I saw, yeah, there's a wisp of smoke there. That's just flux fumes and stuff like that, so that'll happen. Okay, so we're coming up to 220 now. So because the entire board is going to this temperature, theoretically we should be getting close to solder reflow temperature. So I'm going to come over to the microscope now and we're going to see if this guy is actually moving at all, preferably without cooking it. It's a bit violent. I'm suddenly panicking because I'm not practiced, but that's what we're here for. This is the practice run. Hold on a moment. Capture with face cam. Oh, it is. Look at that. It's flowing. All right. Tweezers. Here we go. These are the wrong tweezers. Get the good tweezers. Faster. This is terrifying. All right. Here we go. Oh, I've got the shaky hand. Oh, boy. There we go. Right. Now I'm going to put this guy down here. And I'm going to lift the board off. There we go. Oh, okay, that happened way faster than I thought it was going to. I was not prepared for that process to be that quick, which is why I was kind of panicking there. Right, I'm just going to put that on the silicon cap. All right. Oof. Bloody hell. Right, let's move. I've swung this camera the wrong direction. Okay, there we go. Let's get that camera out the way. All right. Wonder if you can reheat your coffee using one of those. Yeah. Flux it a little bit. Have you used any of these hot plates before, Arnold? The thought occurred, like, should I put some flux on the hot plate to help transfer the heat better? Is that your suggestion? Because the thought had occurred to me to do that. Because where we're working at like 230 degrees here, the flux doesn't just burn off. It actually hangs around. Flux on the chip. Oh, right, I see, yeah. Yeah, that's fair. After you fix the thing, can you try reheating your coffee? No. It's probably going to crack the mug. It'll probably crack the mug. Right, has this guy cooled down? Yeah, that guy's cooled down now. Right, so let's take a closer look at this thing. So I need to do a little bit of looking very closely. Let's zoom in. Let's switch off the hot plate for a sec. I'm going to put that just out of reach before I inevitably burn myself on it. Okay, so now I'm going to quickly bring up Discord so I can check my other reference. Let's see. And I'm just going to open up the pictures of the fault so I can show you guys. All right, so desktop capture. So here's the board layout, and it is these two ground pins in the top right here that are the problem. These pins are relating to the serial bus system, and I haven't read it in detail, but basically if my memory serves me, the B&O chip itself is not properly implementing the serial standard. And in order to fix that, these pins need to be left floating, not grounded. So in the original design, they were grounded, which would have been correct, but the B&O chip is weird and they need to be left floating. So these pins here, which are these two guys, are connected into the ground plane, and we need to isolate these two pins from the ground plane. So what we need to do is cut along these red lines. Now, the reason this one is easy, we could have done this without removing the chip. The problem is this guy here, which is under the chip. This is why we had to remove the chip first. So yeah, basically we're going to cut the ground plane there and across here to isolate these two pins, and that theoretically should fix it. So that's the plan. All right. SDO looks sus, kind of like a bridge formed. Let me go back a sec. We'll have a quick look. Capture with face cam. There we go. Where was our SDO? Oh yeah, agreed. So that had solder paste on it. I'm not using that pin, so I will clear that pin. Let's see. I'm not going to wipe the board down. I'm going to try and just flux and reflow on this. So yeah, I'm just going to quickly wick that. I'm going to wick that bridge clear. But yeah, that's a good catch with that one. Where's my... There we go. I'm powering the hot plate and my soldering iron from the same power cable, so I'm having to do a little bit of swapping around. Right. I will clear that bridge now just to make sure that that doesn't happen. I think that is just solder, to be honest. Sorry, I think that's just flux, but we'll clear it just to erase any doubt at all. Let's just turn this around just so I've got an angle on it. Are we up to temperature? Yeah, we are. There we go. Good enough. I'll clean that up once we've flowed the chip back on, because we'll put more flux on here before we're done. So, do you reapply solder mask? I don't myself, no. I don't do a lot of work like this though, so which is why I'm not in the habit of it. Okay, so time for scraping. I don't have any proper tool for this, so I'm going to scrape it. Right. Are any of my knives actually sharp? This one feels sharp. Yeah, that'll do it. Okay. All right, here goes nothing, everyone. So I'm going to put this down on the table. Right. So just for scale reference, that's my little finger. That's my little finger, so that's the scale we're working on at the moment. And this is a craft knife. And this is a monocular scope, which means I don't have any depth perception right now. Come on. Right, I've done a bit of a cut there. I'm going to try and do 2 cuts, just so I can actually scrape away a slight void between them and be sure. It's harder than it looks to do this in a tidy way that doesn't look ugly. And also I'm trying to move slowly without slipping and gouging a scrape across the whole board. This might be easier to do with a scraping tool, actually. I think a grinding pencil would just be way too big. Oh, this guy's way too big. Never mind. This is a dental pick. Yeah, that ain't going to do it. Knife is the only thing that's vaguely accurate enough. I need to get in closer as well. Get right up close so I can see what I'm doing. That's better. All right, here we go again. Right, so firstly, this guy's trace is going down there, so it doesn't matter if I come across here too much. Oh. This blade is also got the tip broken off. I might switch out to just a fresh blade. That might also make my life easier. Oh, there it goes. There you go. Did you see that? The little bit broke off in the middle. That's what I needed. Let me grab a toothbrush and we'll just clean that up and see if that's done it. A Dremel wheel. Let's just have a look at how big a Dremel wheel is. Here's a Dremel wheel. Good luck. Good luck. Right. Yeah, that got it. I think, yeah, I tell you what, let's grab a... Where are my blades to hand here? I don't know where my new X-Acto knife blades are. Where's my other knife? Is that one any sharper? What's going on here? Hello, Chris Herford. I am modifying... That one's also broken, but whatever. It's got an edge on it. Right, yeah, that is separated. I'm pretty confident about that. I'm just going to see if I can just widen that just to get beyond doubt. Again, once I've done this once or twice, I'll get faster at it. But this is the test run, so... Okay, that is undeniably cut. There's no way there's a connection between those two now. So let's go for the other one. So now I need to cut... Now I need to cut across here. Or all the way down to there. But yes, hello Chris Hertford. This is a sensor module. I have a panel of 28 of these, and I'm fixing a design defect on them to see if I can use them. Oh, this bit is a lot easier because I've got more space to work with. Oops, oh that veer's fine. That's alright. I probably shouldn't have come across here onto that veer. Yeah. Come on, don't slip. Right, hopefully I've just scraped a little line out from between there. There we go, there it goes. That's what I want. Not quite. I've taken off a bit, but not enough. Will there be blood today? Hopefully not. Could masking the pad under the chip work? You know, I'm wondering that, and I might attempt it. You'd do a wider cut on the pin. Yeah. I'll have a look at that in a sec. Like, this is one method of doing it, and I feel like it's a little bit jank, and I do want a better method. I had visions that I could put some Captain tape over those pins or something, but it's way too small. It's way too small to get Captain tape under there. There we go. That's definitely cut. We'll check these connections in a minute. Solder mask might also work. What I'm worried about is leaving too much of a bump, though. Right. Yeah, I'm pretty sure that's separate. All right. Let's do some continuity testing. So, multimeter in beat mode. Okay, so get onto U. This is slightly beveled. Right, so these two pins are connected together, but they're isolated from ground. As you can see, this capacitor goes over to the ground plane, but because we've cut down there, it's now isolated. And just for posterity, we'll check up here. It should all be common ground. Yeah, and we're not connected up there either. Whereas by comparison, these guys are all connected. Yeah. Good. Op success. All right. Grind the pad away. That would probably also work. Yeah. What I might do, once I've done this one, on the next one I want to try different methods, basically, and see what works best. I think that will be interesting. Right, so now we've got to put the chip back on. So I'm going to have a quick look at the chip. Right, there's our dot, so the chip goes on that way up. Right, so what I'm going to do, I'm just going to put some flux on here and just reheat it and just see if it flows back on again. I'm just going to see if it's that easy without doing anything else. Do you need to separate those two pins? They're connected now. No, you don't have to isolate those pins from each other. According to my reference material, separating those two pins is optional. Right. Okay. Flux. Oops. And flux. Cartoon splat noise. Just get that knocked roughly into alignment. That should do it. Right, so when I reflow this, we should see it just settle on the board. Perfect amount of flux. 1 millipole of flux. All right, let's bring the microscope all the way up now. Push that to one side and get the hot plate. Plug the hot plate in. Put that on top of the hot plate. All right, so now I'm going to heat the hot plate. Low volt again. Why does this thing keep negotiating low power? One more try. There we go. I flipped the connector over. All right, the hot plate is heating up. 60 degrees and rising. So we should see this start flowing, and then I need to give it just a little nudge with the tweezers. There's the flux melting. However, we're still at 90 degrees. We're not enough for solder yet. Come on, stay in the middle. Okay. Here we go. 130. 150. We're aiming for 230, just as a reminder. You might re-bridge the cut trace under the chip when reflowing. Yeah. Oh, there it goes. Look at it go. Right, I'm just going to give it a little nudge now. Oh, look at it. It's beautiful. Oh, no. Oh, I fucked it. Okay, hold on. I can fix it. I can fix it. I nudged it too hard. Come on. Skip across. No. No. I've broken everything. All right, hold on, hold on. I had it. I had it. I just wanted to show you what it looked like when you nudged it. You got to be so gentle. Oh, come on. Get back on that. If this was BGA, I'd be turbo dead now. However, there we go. This is why I'm afraid of BGA. QFN, you can get away with that nonsense. BGA, you'd be done. You'd be mega dead. All right. Too much flux, it's floating. Yeah. Let's see. I mean, let's cool it. If I can figure out how to tell the thing to cool. That's the timer. That's M2. No, I don't want to go to different profiles. Nope, hold on. Okay, I'm just turning the damn thing off. Oh, shit, hold on. Ah. Okay, we're cooling down. Yeah, I unplugged it, and where I went to pull the plug out, I then knocked the microscope and everything fell over. Touch it with a cotton swab to drain it. Oh, that's a good idea. Will that work? Oh, it might still be floating. No, I'm going to leave it for a sec. What if I heated it while I was pressing down on the chip now? This is why you save the manuals of devices you don't use all the time. Yes, I have got the manual for this guy, just not to hand. I do remember the first time I used this thing, it was just really unintuitive. Once you know it, it's fine, but... Cut might get filled with the pressure, yeah. To be honest, I might just try this. I might just YOLO this. Are we still molten? I dare. Yeah, oh, it's still going. Yeah, we're still cooling. I'm gonna take the board off of the thing. Where's the... There it is. Hold on. I've just taken the board off of the hot plate so the board can cool down. Once the solder goes hard, pin and reheat. Yeah. Well, we'll try both. I'm kind of... Part of me wants to just stick it on the board now and see what happens. But the other part of me is like, I can't leave it with all that flux underneath. Maybe. I don't know. Hello, Sleepwalker. Late today, work sucks. Sag. I am attempting to repair defective BN085 IMUs. When it's cold, test the continuity. Yes, I will. Yeah. All right, how are we looking? Yeah, that's solidified. That's gone hard. All right. Inspection time. I mean, it's soldered on. I agree. The problem is the risk of flood filling that cut. We need to, if we made a bigger separation under the chip, we'd be okay. Flux can be cleaned with the ultrasonic. I could do, I suppose, yeah. Yeah. Where's the Caradog today? He's at a wedding. Yep, a wedding in Monaco. Yeah, that's it. We're gonna make that's canon now. Caradog's in Monaco. All right. He's at a wedding, and yes, we're now assuming that he's in Monaco. And next week, without telling him anything, next week, just everyone ask him how was Monaco. So, right, okay. Ultrasonic for flux removal. Yes. Good. I'm going to alcohol this and test it. Oh, is it usual to have to deposit some money for a lease in the UK? Yeah, everyone has a security deposit of some kind, whether it's security or insurance or money up front. You know, you have to front some money for a deposit just to show you're good for it. Let's put this on the desk. All right. Beat test. This is taking so much longer than I anticipated. I shouldn't be surprised, but if it works, though, to be honest, if just this one works, I'll be happy because it's proof of concept, which is all I wanted to achieve today. I just wanted proof of concept. Okay, right. So, So we want a ground point. So there's ground. Right, so sitting on ground. So ground. So this pin here and this pin here should not have a connection. Nothing. Nothing. However, another pin that goes to ground still goes to ground. Good. It has worked. Whoop. Can't believe Caradog is in a wedding band. Right. Always the maid and never the bride. Alright, so we have achieved it. So what we've done now is we have isolated these two pins from ground by cutting the trace here and underneath the chip. So this should fix the high power consumption on this module. So now we should find that the module still works, but now doesn't consume 1,000,000 milliwatts. So what I will now do is I'm going to put some test pins back on it, and we're going to stick it back on the board and test it out again. Right, let's switch back to the bench cam. Ooh. I'm going to get a nice new set of pins. I'm going to stop messing around with broken pin headers. Get a nice shiny new one. All right. Put you face down a sec. Soldering iron. Bald, yeah. Masking the contacts with curable thingy is an option. Yeah. The next one if this works, I'm going to get another one out. We'll do the same thing, and we'll do the same, and we'll see what other options we have for masking or just doing a less violent repair. Because I don't like the idea of cutting the traces, just because it's very difficult to do that cleanly. It's very difficult to do that in a way that just doesn't look ugly. And, you know, I don't mind how these things look because they're cheap, but it would be cool if we can find a really slick way to fix these guys. Oh my days. Right. We on shot. Let's adjust the camera a little bit. There we go. Didn't need to solder all of these pins. I only needed some of them, but whatever. Desoldering gun fixes all of that. Ah. Put you on the floor for a moment. And then I'll get mad when I can't find it in a minute. Alright, test jig. Needs to go there. So let's plug it in using the cheap until you need 10. Yeah. Because like any DIY projects, you've got to have spares. This is true. Yeah. All right. I don't know what BNOs are like for reliability. Right, plug in. Meter on. Oh, I can see it from here. 86 milliamps, everyone. Pushing up to 96. So it's a bit thirstier than the BMI is, but we've taken 100 milliamps off the power consumption. And touch test. And it's not burning up anymore. So now we just need to see if it still works. because obviously this is completely immaterial if it doesn't work. Spoilers, it works. All right, hold up. Desktop view. For those of you just joining us, this is a Slime VR body tracker. It's designed for body tracking in VR, and this is the bit that we're working on is the sensor module that detects position sensor, accelerometer, gyro, etc. Preview. Bam. There we go. That is one fixed BNO. Love it. Love to see it. Now, it's taken me nearly 2 hours to do that. However, now we've done one, we can do many. Happy days. Happy days. That's a good result. Excellent. Right. Bench cam. Good. How much does a complete sensor, processor, and battery end up costing? So there are lots of variables to this. However, for rough ballpark figures, I'm going to leave this on for a sec just to see how hot that gets. Because when we started out, while it was using 185 milliamps, it was uncomfortable to keep my little finger on top of the chip. You know, I could put my finger on there and be like, "Oh, that's getting uncomfortable." So it would have been up at about 50 or 60 degrees C, the chip. So we'll just leave that to sit for a while and heat up and see what it does. So yeah, rough things. So the MCU, you can find these for about, so going with small quantity without buying in large quantities, you can find D1 minis for about £3 each on Amazon. Like this is a cheap £3 Amazon one. Sensor units, these BNOs are expensive. I'm paying £6 each for these ones, which are the defective ones. If you're not buying defective ones, I'd be expecting to pay £8 or £9. But you could also be buying BMI 160s. This is a much cheaper sensor. You can find these guys for £2 or £3 each. And again, that's small quantity. If you buy large quantity, they're cheaper again. So you're looking at like, call it £5 or £6. Well, so if you build with a BMI 160, which is cheap, you're talking £5 for the MCU and the sensor. A small LiPo cell is going to cost you a couple of quid. Let's call it £5 for a small LiPo cell. It's going to be cheaper than that realistically, but whatever. So that's £10. Some wires, a couple of resistors and diodes that you want will be another couple of quid. So your bill of materials for this is going to be, you know, £10 or so, that kind of area, maybe £15. If you have to buy cases, that might be more expense. So let's say £10 or £15 or $10 or $15 per tracker, and you want a set of say at least a set of 8, I would say. So let's say £12. So 12 times 8. So you're talking £96 with those ballpark estimates. So you can build a set of trackers for less than £100. And if you buy in larger quantity, that number is going to come down by a lot. So if you're building in quantity, you're going to be coming down to more like, £80 for a full set. And typically, like, if you want to buy a set of trackers, I would be expecting to pay between £150 and £200, However, that's, again, for a full set of 8. Now, if you put this in comparison to something like Vive trackers, you're going to be paying £200 to £300 for one. So that gives you a rough idea on how good value this system is. You could sell these trackers. That's kind of the plan. It's not going to be a long-term business venture, but I paid a lot of money for these, and I do plan on getting that money back. So that's the idea. Now I know I can fix them. That's the idea. What would you use to put grommets back into hinge housing? What kind of hinge and what kind of grommets? Generally speaking, just tweezers and a lot of faff. Right, how's this guy feeling now? Power consumption is still 85 milliamps. and the chip is cool to the touch. So this is 100% fixed. Cool. Right, let's do another one and let's explore... Camera. Let's do another one and let's explore what other options we have for doing the thing. So do I need to reflow this, I wonder? I could, but I think I'm going to leave... I'm going to call that one and done. I don't see a reason to touch that. I think it's fine. Just for posterity, though, let's give it some abuse. So you can see the power consumption there. I'm just going to press on that. I'm going to abuse this. I'm pressing down. I'm pressing down on the chip. And it's not doing anything untoward. So yeah, that's stable. If I press down on that chip and the power consumption shot up, or it wildly swung about and did crazy things, that might imply that there's a bad connection under there, or the risk of a bad connection. However, I've just, I'm pressing down on that. I'm not being gentle here. I'm giving that abuse, and it's fine. And it's still, according to Slime VR, once again, desktop view, you can see the preview at the bottom corner there. That's still reading position. It's all good. 100% success. Good. Number the board. Yeah, maybe. Let's see. Bench cam with face. Right, let's just unplug that first. Number the board. Let's see. Let's take the board out first. Oh, these pins are a bit vicious. Come on. Ow. How can I number this thing? I could Sharpie it, but it's very small. Just put a tiny little 1 on it for now. I don't know if I'm going to keep writing numbers on these, but 1. Okay, that'll do for now. While we're experimenting, I'll number them. So I've got a track of what I did to what. Once I've done a couple of them and I've nailed it down, we won't need to number them, but that'll do. Laptop hinge. Grommets have come out of the top lid. The hinge is flapping around in the breeze. I don't know what you mean by grommets. I guess you just mean like the brass mounts, because grommet to me is usually a rubber ring or something like that. But yeah, if you mean the brass screw mounts have come out, you need to replace any plastic that is broken, basically. So yeah, hot melt glue. If you want to use the Soldering method, good luck. I still don't understand how that works for him. If it works, I'll take his word for it, but you won't. I wouldn't be doing it that way personally. Right. What are the uses for these? These are for VR tracking, body tracking in VR. So if you play VR chat, which is of virtual reality chat rooms, your avatar in that, so your character model in VR chat, moves in real time exactly where your body is. It makes the game much more immersive. Good. Right. Okay. Another one. Here we go. Now I've got 1 out of that panel. It's a lot easier. Okay. Right. Time for the terrifying hot plate again. Here we go. Put that on there. Get this guy powered up. Epoxy. Gluing has never worked for me. I've tried gluing a couple of times because, it would be great, but I've never had success gluing hinges back together. I've tried. It's never worked for me. Right, let's move that to one side and bring in the microscope. Capture with face cam. Yeah. Again, for people for whom it has worked, cool. I'm not dissing you if it's worked. I've just never had any luck with it. So I just replace parts. Activate. Okay, right, we're heating up again, everyone. What was that? I just saw a glint there. We're only at 100 degrees. Yeah, fair enough. Now, I really wanted to try doing this with hot air. However, I gotta say, this hot plate, like, it was very dramatic earlier on just because it was a lot faster than I was expecting it to be. But because we're only working at 230 degrees C, it feels so less brutal to the parts, you know. Yeah, it heats up quicker than I think, and I'm just like, oh, we're flowing. But compared to the violence that is the hot air rework station, this is really chill. I really, I guess I should try hot airing one just so I can establish whether it can be done with hot air. But the hot plate is amazing. If the thing you're working on is small enough to go on top of a hot plate, this is so much better. This is so much more just safer, if nothing, just because I'm using less heat. Come off. There we go. Move the chip out the way. Take the board off the hot plate. Unplug the hot plate. Put the hot plate somewhere where I won't accidentally stick my elbow on it. Put the board on the silicon cap to cool down. Okay. How much was the mini hot plate? I can't remember. I bought mine. Second hand. Sorry, open box. Let me just check. Actually, Amazon. I'm going to use the Amazon price as a worst case scenario. MHP 30, I think it is. Yeah, brand new on Amazon. They're about 130 quid, maybe, depending on who you buy it from. Has anyone got one on Prime? The price varies a lot. 130, 140. You can probably find it cheaper if you shop around. That kind of money. The problem is that it's not very big, so it's only for small things. Like, this is the first time I've ever actually used this hot plate in anger. I just bought it because it was a thing that's useful to have on hand, and I'm glad I had it because now, at a time like now when I actually needed it, I had one. But this isn't something that I would expect most people to have on hand. So I do want to do a test and see if I can do this with a hot air station, because a hot air station has a lot more utility. It's just very cool. More used to seeing the big ones that people use for assistive heating. Yeah, I want a big one, but they're expensive. I should get one though. Okay, right. Has this guy cooled down now? It has. Good. All right. Why not hot plate 5 to 10 boards at a time? Yeah, I could probably fit 2 on this hot plate at a time. If I had a big hot plate though, yeah, you could do multiple. Right, so how do we isolate? Let's zoom down. All right, so how do we isolate these 2 pins without cutting the traces then? So I could, this is too small to put, this is definitely too small to put Captain tape on. So I could wick the pads flat and then put some conformal coat on them. So I'm going to do that. I'm going to try wicking the pads flat first. Oh, do them all at once and then test later. Oh, yeah. Okay, yeah, that makes sense. Yeah. Yeah. Yeah, again, at the moment, I'm just testing methodology. Once I've decided on which methodology I use, then I could do it en masse. However, yeah, right now, today is all about testing methodology and practice, basically. Okay, I need the soldering iron. I should have gotten just another USB power supply for the hot plate. However, I think we've got time for... we'll do a couple more. Because, yeah, as I say, testing methods. Wick the pad on the chip too, if possible. Yeah. We'll have a look at that in a sec. That might be slightly tougher, but I'll see what I can do. Right, I'm going to turn this around. Let's put it on the table. We'll just have to put fresh solder on these pads. That's fine. All right. So those guys are flat. Now the chip. Pin 1 is in the top left, so it's the bottom right 2 pins. Now it's the top right 2 pins. Bonus flux. Heck, that didn't go very well, but that should do it. This is going to be very difficult to do without the chip just going for an adventure. Not convinced about the methodology here. Top left. Are you? Yeah, that's what I thought. Yeah, I was going to say, are you sure, Lead Farmer? And then I just saw message retracted. All right. There's one. Meh. That should do. I don't really want to apply the soldering iron directly to the chip because I don't want to put too much heat into it. You missed the flip. Oh yeah, that's cool. Yeah, no worries. Fine. All right. Okay, that's cool. I'm worried about it being uneven, basically. So we're just going to YOLO this and see how it goes, I guess. Right, so now if I clean that up and put some conformal coating on it, let's see how that goes. So alcohol and cotton wipe. And I'm just going to blow that dry. Blow dry complete. Right, so that's nice and clean. Right, conformal coat. I shall apply it with a pin. So, nozzle is enormous, so I shall use this pin to just swab. Easy. Oh boy. Heck. Okay. And direct that down there. There we go. How's that? Just going to get a bit of tissue. Yeah. Can I take off some excess there? I could. Yeah, I can take off a little bit of excess. Cleaning the tip as recommended. I'm going to quit while I'm ahead in a minute, because in a minute I'm going to slip and just spread it all over the board. Yeah, I'm absolutely going to quit while I'm ahead now. Alright, so I've got a little UV light. However, I'm told that hot air works just fine with this. Solder mask. Okay, yeah, sorry. Yeah. Oh yes, curing solder mask. This is what I'm using just for posterity. That's what I have. going to make reflow more difficult due to it being uneven now. That's exactly what I'm afraid of. That's my concern for this method. All right. So, yeah, blacklight. Okay. Right, where's my little torch? My little torch is super jank. If I can find it. Balls. Has it gone what? Has it gone for? There it is. All right. Believe it or not, I power this from my power supply because the original torch that I got this from, a battery on it burst. By the time it got to me, so the torch body was completely useless. So I now just power it from a bench power supply, which is mega jank. However, it functions. Alright, just turning on the power supply. And current limit to about 100 milliamps. I have no idea what I should run this thing at. Can never remember. So it's getting 1 volt and 100 milliamps now. It's illuminating at any rate. Right, I'm just going to sit like this for a moment. Hello, Muerto. How you doing? Quickly before you see... JD, how dare you? I think I've been doing really well so far this afternoon. I think I've been doing really good. I'm fixing inertial measurement units, Muerto. I've got... it's probably 3.7 volts. Yeah, I'm current limiting it. How much current do you reckon it uses? You too. Well done, well done. Yeah, so Muerto, just for... I'm there. I have inertial measurement unit boards, which I used for my Slime VR body trackers, and I'm fixing some defects on these fancy ones. 500 milliamps. Oh, okay. I'm going to give them some more then. If it burns out, then I'll just have to buy one that isn't broken. It's certainly a lot brighter than it was now. How long is this supposed to take as well? That's the other bit I don't know. Let me get my tweezers so I can poke it. Ah. Oh, it's working. It's working. Yes, Muerto, we're covering connections. Basically, to cut a long story short, these sensor modules, these two pins that I've covered are connected to ground, and they're not supposed to be. It's causing the chip to draw far too much power. So we're breaking these connections so the chip doesn't pull too much power. 30 secs. I think we've definitely had that. I managed to scrape it with the thing though, although we were at low power. How's it looking now? Is it still scrapable? That seems okay. I can scrape it, but it's not coming off. Personal opinion, pull the pads. What would be your method for actually pulling the pads? The first one, we cut the traces around the pads. How would you pull the pads off the board? Because what we're doing at the moment, we're trying different methods of doing this. I've got 28 of them in total, so I'm trying to figure out what the best method for this is. That's the actual plan. Okay. Sharp knife under. I'll give it a try then, yeah. We'll try that on the next one. I think this one's going to be. I think this. Oh, it's not standing up too much. Oh, it's actually no. That's pretty flat. I think we're going to be okay. All right, let's roll with that. Right. Okay. I'm going to give that another poke with the tweezers now. Oh, that's pretty good. I could scrape that off if I tried, but I've got to actually scrape away at it now. I don't have a lot of practice with solder mask. Yeah, that's hard. Under my fingernail, that is hard now. Good. Do I have any toothpicks on hand? I don't. Yeah. It will wick up some of the coating. Oh, yeah, that's neat. Yeah. Yeah, wooden toothpicks. That's a good idea. Okay. Right, let's stick the chip back on the board. So I need to tin up 2 of those pads that got wicked. So I'm going to heat up the soldering iron. Actually, I'm coming in with the small soldering iron to tin up those pads. Because I don't want to... this might have been a mistake, actually. Whatever. This is where we live. I'm trying different things. You're building some more things. Oh, interesting. Yeah, I will be. I'm not doing them anytime soon, but I've just I'm planning it at the moment, basically, and I want to use these IMUs because these are BNO 085s, which are the super mega good IMUs, and I got these ones cheap because they're defective. There we go. That's it. Oh. Right, did I just completely ruin that solder mask then? I nudged it, but I don't know if it will come good again. Shave mask and relight to harden more. I don't think it's going to be necessary, but I'm just going to try this and see how we go. Like, if we were doing a repair where I had one shot, one hope, one dream, and it had to be perfect, I would try all of these things. But because I've got 28 attempts at this, so I want to see what it takes and what it doesn't take. So, like, right now we've put that on there. We've got a little bit of a bump. We've got a little bit of a bump there. That might cause a problem. Let's find out. Let's see if that's a problem or not. All right, so flux. Less flux this time, because we had too much last time. Need to add solder last pad of the same row. Do you mean that one there on the far left? I think that's okay. It has some solder on it, and don't forget the chip also has solder on it there as well. So I'm going to roll the dice on that. I'm going to try it. I'm going to see if that's good enough. Okay, right. Hot plate time. Dry fit the chip. That won't work because when the solder melts, everything will move. So, yeah, like I can look at it now and it'll look wrong, but that doesn't tell us anything. Right, hot plate. Oh! And that is why we unplugged the hot plate. There we go. Right. I removed a lot of solder from under the chip. Yeah, I did. Let's find out. If it doesn't work, we'll know why. However, if it does work, it shows something. Not trying with a hot air station. I'm going to do that on the next one. I'm changing one thing at a time. All right. Hot plate. Boop. Activate. The hot plate is heating. You're back. Guess things haven't been going so well. Actually, they have, Quentin. This is board number 2. Board number 1 was a complete success. So board number 1, we cut the traces, and it worked a treat. So this is board number 2. We've applied solder mask to cover the traces. Let's see what happens. I'm going to give that chip just a little nudge. Oh my god. No, just don't. Nope, I'm going to trust the solder and the flux to do the rest of the work. 150 degrees. If it works, we prove miracles happen due to streamer luck. Oof. Big oof. Yeah, okay, I'll let you have that. I wouldn't recommend this, you're right, however. So the solder mask isn't going to melt, is it? Because the soldering iron was able to melt it. Oh, that's going to need a tap, I think. These lower pins don't look very good. I'm gonna wait for us to come up to temperature. We're just approaching 235. All right, that's 235. I'm gonna nudge it. I'm gonna do it. Here we go. Oh. I think it's sitting on the solder mask. Come on. It's on, but it doesn't look on. Top down. Yeah, all right. See, I think that just sunk into the solder mask. Let's take that off and see how it looks. I'll keep the hot plate to one side for a sec. I don't think that's taken. Solder mask should have been shaven. Yeah, I don't think that's worked, but we're going to try it again. The problem is, if the solder mask takes a huge amount of fiddle work to apply, then that would work if you were doing a one-off repair on a board. But when you've got another 20 of them to do, I don't want to be sitting and shaving off solder mask, basically. I'll just cut the trace. If we have to shave the solder mask, what we're proving is that solder mask is not the right play here. The cut is faster, yeah. That I think is undeniable at this point. However, basically, when I go back to the Slime VR Discord and say, hey, I fixed the BNOs, I want to tell them what worked and what didn't. All right, let's just come down for the big close-up and just see what that looks like. The Dremel's way too big. The Dremel is like a sledgehammer here. Oh yeah, no, not even slightly. Not even slightly. Yeah, no, that ain't happening. I could try and soldering iron that to make good. And in fact, I think I will. I'm going to go in there with the soldering iron and see if I can fix that. Because other than that, Arnold's absolutely right. You'd need to shave down the top of the solder mask. It's just too big. But like, man, I'm not shaving down soldering mask on a million boards. So yeah, I think you'll be surprised how easily the pads will lift with sharp blade. That's what we're going to try next. That's going to be the next method. Okay, right. I'm going to see if I can soldering iron hero this. So let's go down to the table. I'm going to just switch off the hot plate because we're not doing that now. Hot plate to one side. Small tip. Okay. Let's go for the close-up, I think. Okay. Soldering iron is up. This tip is butchered. I think this tip has fallen on the floor. You can see that big old, like, that top shape, that's where it's fallen on the floor and bent, I think. Oh, and it's now not sharp enough to get under there. Can I just turn it over and use the edge of it? I think this tip is fucked. Will the knife edge actually reach in there? I'm going to post you some Swan Morton 0103 blades. Potentially. Right, hang on a sec. I'm just, this is cold at the moment. I'm just seeing, oh, that'll go in there. The knife edge can do it. Stay with the knife edge. Do you have a drill bit for proto board? That would do the pads. Yeah, that's an interesting idea. I think just cutting them is a good idea. I think Muerto is right on the money with that. Literally just cut them. Because we cut the traces the first time and that worked just fine. The solder mask was an interesting experiment, but it's definitely not the right play for mass production, so to speak. That was horrifying. I need a new micro soldering iron. Right, I'm just flowing these pads and I'm just hoping for the best here. Is that doing anything? No. I think we should pull the chip off, take the solder mask off, and pull the pads on this board. I think this is a bust. Check if SDO is bridged again. This one's okay. Oh yeah, well, I'll check that again anyway. Yeah, I think this is a bust. I think we should abandon this attempt. I'm going to try one more time to get some solder under there. Put some solder on the back of the iron here. I'm going to get some more flux in there as well. That may help. That may well help me out. Here we go. I don't know. What about the side pins there? Yeah, those guys are out as well. Let's just give that a quick poke. If I had a better soldering iron for this, no, I'm out. I'm out. Let's pull the chip off. Let's start again. Solder mask, not the play. It could be done. It could be done, but not without a lot of hassle. Not worth it. Whoop. Right. Readjust. Hot plate. Go. Louver. Oh, you bastard. Come on. Don't toy with me, Miniware. Miniware, please. No hot plate. Ow. Come on. You bastard. Okay. Oh. Stand by. Okay. Power up. This is the last run with the hot plate anyway. Oh, low volt! Stop it, you... I'm begging you. Just heat one more time. Okay, there we go, we're heating. Right, this is the last run with the hot plate anyway. We've proven that the hot plate works, but I want to do hot air on the next one. Right. Tony W, you got some Paul Daniels bogan neighbours fisting you at the moment. Why? Are you guys hearing a lot of outside stuff? Was there some drive-by stuff just then? I wasn't paying attention. The bigger one called the MaxiWare. Might be able to apply a thin layer of mask onto the chip instead. Nah. Not feeling that, but not based on any kind of knowledge. Okay, right, so we're taking the chip off the board again, and I'm going to scrape off that solder mask, and we're going to rip the pads up. That looks like reflow. Hypothetically, just humour me for a moment here. Humour me for a moment here. Off the hot plate, onto there, press down. I'm probably going to melt this silicon cap slightly. It looks slightly wonky, yeah, but I don't think it's enough for the pins to be out of alignment. No, just no. No. Get in the pan. Get in the pan. Oh, this capacitor over here. Yeah, I'll straighten him as it comes back up to temperature. This guy's been reheated quite a couple of times now, so it's suffering slightly. This will also be an interesting test because we're giving this board quite a lot of abuse. So again, if this one survives the process, that shows that the boards are actually pretty hardy, and the chips as well, because I want to know how delicate these chips are. There we go. Right. Off. Unplug hot plate to one side. Right, that's cooling down. I'm just going to have a quick look at the bottom of the chip. Oh, which tried to melt its way onto the pad. Yeah, that guy's fine. It's a little bit kludgy on the bottom, but that will clean up when we flow it back on. Might require pressing down when we reflow, but that's okay. All right, time to scrape. Tiny piece of Captain tape. It's too small. It's too small. Yeah. Again, it's just the scale we're on, trying to get a piece of Captain tape that small to stay in place. I don't know. I think that's a long shot. Right. Okay. Time for scraping. Oh, this did actually go pretty hard, this stuff. We're probably going to make a bit of a mess of this. Maybe if I scrape sideways to try and get under it. Would that work, I wonder? Scrapey, scrapey. Can I get under there? Not quite, I don't think. Although ironically, with the amount I've shaved this down, I've probably taken off the height that needed to go. If I start seeing blue instead of green, I've gone down too low. There we go. That pin is starting to appear again. There's a white line indicating the edge of the chip and then the actual pin itself. There's the pin. There's the other pin. Alright, I think that's the solder mask done. Let's clean that up. Whew. Wah, wah. Okay. That's burnt flux there. All right. So now let's try and take these pins off then. Right. So okay, so now we've got to lift these pins. All right, so the problem here, this one probably isn't too bad for lifting it because it's a pin. However, this guy is more or less integrated into the ground plane. So I don't know how well this is going to go, but I'm just going to try and get straight under there and just see if I can just cut under the pin. I don't know what I'm doing here. I'm making this up as I go along now. Oop. Eh. This is horribly violent. Honestly, cutting the trace so far has been the best way forward. Dig lever the edge out. There isn't an edge. That's the problem. Because it's all on the ground plane. Like, for example, this pin here is not connected. That guy would just flip off really easily. These guys are on the ground plane, so they're part of this big plate of metal. So it doesn't just peel off. Previous video you managed to lift. Yeah, that's... yeah, when you're on the ground plane, that's not the case. I think by the time I've cut this guy out, we could have just cut the trace anyway. Cut it where it joins U2 and lever. Let's try it. Tongue at the right angle. This whole ground plane has to come up for that to happen. No. Well, it was... valiant effort, but I think because we're on the ground plane here, I think it's actually easier just to cut the trace. How long is my longest repair? It's hard to say. I don't tend to time them. We've kind of obliterated this trace, but it was kind of such a messy, violent affair that cutting the trace would have been easier. We'll keep going just for posterity. Yeah. Again, if these pins... balls. Come on. If these pins weren't on the ground plane, they'd come off a lot easier. Can you not Dremel? Once again, here's a standard Dremel cutting wheel. That's how big the Dremel cutting wheel is. We'll cut the board in half. I would need to get a really fine Dremel bit. What you need is the people who use electric tools, they have a tiny Dremel pencil. Like it's a micro Dremel, it's a tiny one. It's not a conventional Dremel, it's a tiny little grinding wheel. That's what they're using. And so yeah, that's not a standard Dremel they're using. It's a tiny little wheel that's specifically designed for this. And I don't have one. Oh, this pin does not want to go. Doesn't help that you're cutting with a spoon. Look. I know that I don't have a brand new blade on this, but I know I'm hurting you right now, Muerto. Oh no, the first one where we just cut the traces was so much better. Just trying to get the last of this guy out now. One millimeter's huge. 1 millimeter's huge, dude. We're working way smaller than 1 mil here. I think those holes are... Hang on a minute. These holes are less than 1 millimeter wide. Like, bearing in mind, my butchered micro tip, this is 1 millimeter wide. So yeah, like 1 millimeter is still big in this context. That's the bit that people often don't realize when they're looking through the screen through the microscope, is just how small stuff actually is. You'd need like a 0.8 or 0.6 mil piece. All right, come on. I think I've butchered this pin enough that there's not going to be a connection there. However, it was not neat. The first attempt we did was by far and away the cleanest, by a long shot. Ugh. Okay. Let's just offer up the chip just to see if I've done enough there. Yeah, I'm going to take off a little bit more. However, by a long shot, cutting the trace is definitely the best, the easiest way of doing this. And also having a sharp knife, of course. I will try again to find my new blades in a sec, because I haven't looked very hard, and I have better blades. I might need a sharper blade just to actually fix the mess that I've created here. In fact, yeah, hang on a sec. There they are. They were right in front of me. I just wasn't looking. I was trying to make good with what I had. New blade coming in. Okay. New blade. And I'm going to cut across there just for posterity. Because I've made a bit of a mess of this, I want to actually just cut the section out just to be sure now. Almost. Oh, this last bit doesn't want to go. Let me turn the board around. That'll help. Right. Get out. Get out. There we go. Ugh. Did it. Okay. The pins are gone. We're cutting the traces. We're cutting the traces. You made 2 shorter right angle cuts instead of 1 longer cut from the outside. Yeah, potentially. We're going to go back to... I'll just quickly bring up the reference. So on the first one, for those of you who weren't here from the beginning, these are the cuts we made on the first board. The red lines are where we made cuts. And that one was textbook. It was perfect. And with a sharper blade, I could probably do an even better job of it. That was definitely a better way forward. So that's what we're going to be doing subsequently. So yeah. All right. Could you not mask the pins from the chip? I don't know. Cutting the chip seems like a bad idea. Right, let's. I'm going to stay on focus. Let's get this guy sorted. I'm going to re-tin these pads, just to make sure there's enough solder there. And we're going to reflow, and then we'll make sure that this one still works. And then after that, I've got one more. 10. We're coming up to the 3-hour marker. We'll do one more after this. We're going to run into overtime a little bit because the last test I want to do is to see if I can do it with hot air. Just to find out if hot air is viable or not. Right. Retinning. That'll do. And while we're here, just going to make sure that the SDO bridge is clear. There we go. There's no way that guy's going to fuse. Bottom right pin. It's fine. It has slightly less on than the others, but it's got enough on it. By the time the chip sits down on there, it's all going to squash. Okay. Hot plates. Flux. Chip. Come off the tweezers, please. No. All right. Time for some expert nudging. I need to clean these tweezers. Stuff should not be sticking to them. All right, there we go. That should flow when it comes up to temperature. There it goes. Whoops. There I go, nudging it too much again. Gonna press down on that. All right. I think we've got too much flux again, but that didn't seem to cause a problem on the first one. Ow. Okay. I'm quitting while I'm ahead. Get on off. Bottom right might be touching corner. It might be. We shall find out momentarily. If this one doesn't work, I'm going to cry. I mean, it's had a huge amount of abuse, this one. Like I said, if this one still works, it'll be a testament to how well built these actually are. All right. Zoom. Enhance. Needs cleaning. Okay. Enhance. Drying. Finger drying. All right. Might press down a bit too much on that. However, yeah, we obliterated that section enough that there's no way there's a connection there. We'll continuity check that. I'd almost say that one's sitting a bit too flat for comfort, where I pressed down on it very aggressively. But again, I wanted to see what would happen, basically. Okay, continuity checks. What was the last shop remove one? That came out last weekend, and that was the end of it. Or that brings the shop up to date, that is. So yeah, we're all done with those now. Okay, right. Ground. Get a good join on ground there. There we go. Ground. Right. Ground check. And, well, we can't tell actually because this area is still ground, but we can't reach the pins under there. So actually we have no way of testing this other than to just hook it up and see if it works. If it uses less power, then it worked. If it doesn't use less power, then it didn't work. So yeah, we've just got to actually just stick this one on the board and find out. Okay, fine. It'll be good. They're good when they sit tight to the board. All right, fair enough. Okay, camera swap. Do the outside cut at least. But let's find out if it worked. Because if we cut the outside, then we won't know if removing the pins actually worked or not. Outside cut if it fails. Yeah, I would agree with that. I'm not going to do that on stream. I'm definitely moving to another module now because I want to find out if hot airing works. We have learned everything we can about this methodology at this point, and anything else we do with that one now is just making good, basically. Right, I'm just going to remove my pin stack from this module. Okay, right. Pin header, detach. I'm not sure if I'm going to be able to get this many off at a time. Let's find out. See if I can walk this out. I don't think that's working. Oh, there it goes. I think I butchered the pins doing that. Yeah. Okay, that doesn't work. Right, this guy's number 1. So this guy is fully functional. I'll use some new pins. Shot move 3 due soon? No. No, I am here for the long haul. I'd need to find something spectacular. All right. God, I'm getting tired, guys. Right. Just tack weld in place. There we go. Okay, we need the end for... and that guy. All right. Breadboard. Whew. Breadboard, test board. Let's go. That goes there. Am I on? Yeah, we are on shot. That looks right. That looks right. Yep. On you go. Whew. Good. Right, here we go. Power. Herp. Power meter. Power meter looks good. Power meter is showing 85 milliamps, which is what we want to see. So for those of you who weren't here earlier, before we do the modification, these modules pull 185 milliamps. Whereas after modification, they drop to 85 milliamps. I'll push it in a sec. Let me just check if it's responding first. It is functional. Desktop. As you can see at the bottom of the screen there, the module is functional. And let's give it some abuse. Yeah, that's holding. That's fine. Yep, it's good. It's good. All right, so that was a lot less elegant than the first one. The first one, I kind of thought it was a bit violent cutting the trace like that, but it worked way better. Yeah, it's It's not impossible to do a really beautiful masking of pins or a really beautiful removal of pins. However, considering I have another 26 of these to do, we're looking for a fast solution here. Fast, simple, reliable. Okay, right. One more to do. Last one now. We're just going to try and hot air one off the board and see how that goes. So let's move my ground pin so I've got better access and just take this guy off. Bench cam. Right. So this dude is number 2. It's fairly easy to see which one is which, to be honest, but I'll number them anyway, just for posterity. Actually, I won't, because I've lost the Sharpie. That's a black Sharpie, that'll do. Two. All right. Okay, last one. Oh. Gonna get my heat mat now. Patented Apple heat-proof mat that makes people really angry. All right. Ugh. That felt horrible. All right, so now on this one, I'm just going to try and hot air that off, and we're just going to see if that is less. I mean, so far the hot plate seems to be a really elegant solution to this. However, not everyone's got a hot plate, so I want to know if it's possible to hot air it. Here we go. Whoops, sorry camera. I just nudged you very... Oh, sorry camera. I'm just nudging you very violently there. I think that's a suiting end for a MacBook lid. Yes. I couldn't find my usual heat-proof mat, so I was like, this broken MacBook screen will do. All right. So temperature, I'm going to try 360 degrees. No, 380. Here goes nothing. Is the soldering iron cold? It is, yeah. All right. So hot air. Here we go. It's sure as hell a lot faster. Okay, that was so fast, I'm not even worried about the higher temperatures. I've been praising the hot plate all stream, but that was the hot air. Just bam, off, done. Hot air stations are strong, man. Okay, right. Let's cut the traces. It's also going to depend on. See, the other difference is when we go back on with the hot air, how easy is it to get it nice and lined? Because the hot air is going to try and blow the chip away. So it might be that it's removing the chip is easy, but putting the chip back on with the hot air might be the hard part. So yeah, speed run time. How fast can you do a board one and done? Yeah, let's see. Well, let's just get on and cut this. The board isn't dissipating heat. Yeah, exactly. That made the hot air way faster than I would normally expect it to be. It's a very lightweight board, this as well. All right. I'm just going to clean this up. It's nice and clean. We can see the traces better. There we go. Right, here we go. So we're going to get in there. Slightly out of focus. Let's come down lower as well. I can get closer than that. Should be able to use lower. Probably can, yeah. I will go for that since I've just demonstrated that it takes so little to remove these. This MacBook screen is bending. Whose idea was this? Come on. Ugh. Come on. Move. Alright. That must have done it. I can feel a divot between the traces now. That must have done it. Toothbrush. Oh, I don't know if it did actually. Oh, hold on. Hold on. Get this stupid board out of the way so I'm on a stable surface. I'm rushing because we're 3 hours in and I'm like, cool, let's get done now. Let's slow down and actually work on a surface that is comfortable. I think I'm through. It's just hard to see. Yeah, there we go. That's definitely through. I'm just gently... There's just a little bit at the bottom. There we go. Right, that's definitely through. Anti-speedrun. Yeah, gotta go food. Yeah, it's all very well for you, Sai. That's why you want me to speedrun. You're like, I'm hungry, get on with it. I'm also hungry and I want to finish. However, I had a job to do. Come on. Whew. Is this some sort of mod? Yeah, these are... It's a defective prototype, yeah. Trying not to cut that via there. Alright, and cut under. Whoops. Man. This takes more practice than I anticipated doing this. It's doable. It's not, but it's harder than it looks. I can tell you that much. Like, people who are experienced board repair techs will be screaming at this, but if you've not done this yourself before, I can assure you, it's not like you're trying to cut paper here. I am cutting metal after all. Right, can I just peel that up with the tweezers now? Oof, that went low. Alright. That was a little bit violent, but that sure as hell has cut that connection. So that's why we buy mini grinders. Yeah, big mood. Yeah. Yeah. Okay, right. That's that section done. Chip back on the board, and we're done. Can my heckin' microscope please straighten up? Why is that not holding straight? What's wrong with you? There we go. That's better. Right. Right, heatproof board. and flux. Chip on board. And I'm going to go down to like 25% on the airflow. You're off. No problem, Huerto. Thanks for coming in. Much appreciated. We're about done here anyway. We've just got to put this guy... we just got to put this guy on and test it. Alright, here we go. Nudge, 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 nudge. It's doing a little dance. It's doing a little jiggle. Pressing it down. Okay. Yeah, so for a one-off, the hot air is very quick and simple. But now, when I go to do the rest of these boards, the method that people mentioned earlier on about doing them all at the same time, so just hot plate, heat, chip off, heat, chip off, heat, chip off, and so on, that will be easier, I think, than using the hot air. If I was doing this on like 1 or 2, I think the hot air is better. But for small scale, you know, for doing a number of them at the same time, the having that little hot plate just to place it on and just have the chip flow down nicely is very nice. Too hard to 3D print a cutting guide. So again, remember, we're working on a scale of these holes here are 0.8 millimeters wide. The pin, the actual pin, that is a millimeter. So the scale we're working on is just too small for stuff like this. So yeah. Okay, right, continuity check. Let's get done. We're in overtime. We're in overtime. Let's get to the finish line. Overall, I'm very happy with what we've done today. That second one was a horrifying adventure, but I think we learned, well, I learned a lot trying to do that. So while it was a bit of a hassle, I got the information that I wanted out of that hassle. All right, ground check. And not ground. Not ground. And ground up there. Yeah, there we go. That's all good. It was fun to watch. Thanks. Can you make an overlay out of some other cut-resistant material to limit the cut? Yeah, again, just everything would be too small. Hot air is the way to go. Maybe fire foam. If you don't have a hot plate, what we've just proven is that hot air is 100% valid. However, I think if you do have the hot plate, it was really nice just being able to put it on the hot plate and just watch it flow and be like, there we go, it's done. And then take it off the hot plate for cooling. The hot plate also as well involves just less temperature. So there's no fear of overheating the chip or anything like that. Although the proof will be in the pudding when we test it. Hello, Teltac. These boards, hold on, let me just switch cameras. These boards are B&O 085 IMUs. So these are inertia measurement boards. Let me just fix the camera angle for my Slime VR trackers. Straighten. There we go. Right. So what I've got here is a breadboard for a Slime VR tracker. So we've got a D1 Mini MCU. And my current Slime VR trackers use BMI 160 IMUs as 6 degrees of freedom motion sensors. And I've got here a plate, a sheet, a board of B&O 085 ones. These are much better, but again, for those of you who weren't here at the start, these particular modules have a defect in them which causes them to draw more power than they should, like double the power that they should. So do the remainder of the work before breaking the boards apart. Could do. Maybe. I'll think about it. So the modification we're doing here is to fix the high power consumption on the boards. Right, I'm going to remove my pin headers from here again. I wonder if I could do a quick hot air of the pin headers. I'm going to quickly test that. It's not tight enough. Sort of. I think manual desoldering is... There must be an easy way of removing these pin headers. Must be an easy way of removing them all without having to manually desolder them all. Hot plate would be really handy for jobs like iPad screen replacement. Yeah. This hot plate is too small for it, but bigger hot plates, yeah. I do want a larger hot plate for just assistive heating and stuff. Great fun again. I'm glad that people thought, yeah. I beep it before putting the chip back just in case. Yes. Going to do another test run in a sec. This is number 3 and that pin there. There we go. All right. Home run now. I might buy some pogo pins for testing these, just so I can practice with using pogo pins. How hot would the large hot plate need to get? I'm not sure. To the order of like 100 degrees, 200 degrees. Not hugely hot. See, the thing is, standard solder melts at like 180 degrees, but you have to run a soldering iron and hot air way higher than that because you lose so much temperature in the transfer. But the hot plate, because you've got a big surface area contact, like the mini hot plate here, is heating the entire board. So there is no heat loss because the whole board goes up to temperature. So you only need to go up to about 230. So yeah. But yes, for screen replacements and stuff, no idea. Yeah. Right, let's test this guy. So we need ground and power. And let's check the meter. Meter looks good. There's the quad view. So we are drawing high 80s, about 85 milliamps, which is what we're expecting. And the tracker is connected and it is tracking. So if we go back to desktop view, as you can see from Slime VR, it is tracking the tracker. So that one now also works as well. So yeah. Good. So, okay. Right. Bench cam. That is us done for the night. So what we learned. So firstly, the repair does work. It's not mega difficult for anyone who has small soldering experience. The hot plate is nice, but it can absolutely be done with hot air. The hot plate is not essential by a long shot. I haven't decided which I prefer, to be honest. I like the hot plate. I think they're both valid. They've both got strengths and weaknesses. I think the hot air station is definitely faster. But also, if I hadn't been constantly plugging and unplugging the hot plate, if I just had that powered and just up to temperature on the bench, there would be a lot less drama with it. We had drama with the hot plate because I was having to swap out between the soldering iron and the hot plate and stuff like that. Is this like flashing all the time? I don't know is the answer to that. My trackers with the BMI 160, it blinks every 10 seconds. So I'm not sure why that one is blinking constantly. I don't know if they behave slightly differently with the BNOs in them. But also, if you have it in an enclosure, you can switch off the LED in firmware as well. So yeah. So yes, hot plate is a little bit more AFK maybe. Yeah, I think, but I mean, the hot plate brought them up to reflow temperature so fast because I was originally envisioning that it would take like 5. You know, we would be waiting for a couple of minutes for this guy to do its thing. So I was thinking that we'd have one on the hot plate while I wired up another one or something like that. But, you know, if the hot plate is already up to temperature, you're talking seconds. But again, these are really thin boards. Like, where's the there's the comparison of the BMI 160 and the BNO. So you can see that these BNO boards are really thin. So that's one of the reasons why they flow so fast, is that it's a really thin board. So yeah. You turn off the live reactions. Yeah, I'll have a look at it at some point. So yeah, 2-layer. Yeah. Hot air off the sheet in one piece. Well, the problem there is that here's the panel and here's the plate. So yeah, like it doesn't that's the problem there, is I'd have to hold it there, and like if I'm having to hold it with my hands while I move along, you may as well use the hot air. So it doesn't work on a panel scale. I might be able to do 4 of them at a time if I split them into 4s, but I don't know. So yeah, attempt 3 was very good. It's fully functional. The hot air definitely works. What's that one? Oh, that's number 2. Number 3 is on the board and it works. Hot air definitely works. Yeah, I can't decide. I like the hot plate. It's definitely not mandatory though. Hot air is completely fine. You need to print scissor tables to support, or I could just hot air it. That's the thing. It's just, at this point now, we're making excuses to use the hot plate. If we were using a chip that was really sensitive to heat, and like 380 from the hot air station would kill it, that at that point we could start building a purpose. But again, yeah, we're having to come up with excuses as to when the hot plate is more useful than just hot airing the damn thing off the board. So yeah, but yeah, hot air or hot plate is fine. Slice the traces. That's the bottom line. Do you ever give up on a repair? Oh yeah, absolutely. Absolutely. There are lots of repairs where I tap out on them. However, a lot of them don't make it to the video because I just don't know what's wrong with it. However, if I think I know what is wrong with it and why it's dead and why I'm giving up on it, I'll try and make a video about that. So yeah, I think you'd have more control cutting as a sheet. I think you are probably right. Although to an extent, the problem there is that if I'm cutting on one and I accidentally slip, I might go across the whole panel and then butcher another 4. So breaking them off and doing them in singles might be less risk, because if I have an accident, that I can only break 1. So yeah, could conformal code. We tried that. We tried using solder mask. Theoretically, solder mask will work, but it's very, very fiddly. If you wanted to do something that's a work of art, you could solder mask it, but then you've got to shave it down and stuff. The first attempt we did that, it was too thick, basically. So yeah, solder mask it could be done, but it's too much hassle. Cutting the traces is the easiest method by a long shot. Right, I'm really hungry and I'm tired, and I've been going for 3.5 hours on a high stress, a much higher stress stream than I expected. But it was also a roaring success. I'm very happy with the results we got. So thank you everyone for tuning in. I'll be back. We'll be back next. Oh, I might not be here next week actually. I think I'm away next week. I think I'm camping next weekend. So probably not here next week. Hang on a sec. Where's my phone? Let me just double check it because I've got to make a decision if I'm going to tell people if I'm here or not. Let's actually be right. Let's see. Calendar. Camping. Yeah, camping Saturday 19th to Monday 20th. Yeah, I'm not here next week, so we're probably not on next week. I will give Caradog the option of doing a special if he wants to, but I would imagine we're probably going to take next week off. So I'll see you guys in 2 weeks' time, and we're going to have the freezer up and running, and we're going to be doing possibly some CPU delidding and mad overclocking. Caradog went mad. He's bought loads of stuff for it. So I will be streaming on Twitch tomorrow. I don't know what I'm streaming yet, actually. Oh, yeah, small indie games on Twitch tomorrow. Thank you for the link, Si. I'm getting out of here. We're done. I've enjoyed this conversation in English. I'm going now. Goodbye. Caradog is in Monaco at a wedding. So, yes. All right. Thanks all. See you all soon. Bye. Oh, hang on a sec. That's the wrong place. That's the one I need. End stream.